Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on higher order differential equation of type 1. So in type 1 problem, we have x equal to e raised to ax. So we represent our equation into f d y equal to x, where here x is e raised to ax. This will be our given equation. The solution of this equation is given by yc plus yp, where yc is the complementary function and yp is the integral part. For complementary function, we find the auxiliary equation, which is nothing but fd equal to 0. Then we find the roots of this equation. Then we write yc as c1 e raised to m1x plus c2 e raised to m2x and so on, where m1 and m2 are roots of this fd equation. In particular integral, our yp is nothing but e raised to ax upon fd. In this, we will substitute d equal to a, provided f of a is not equal to 0. When f of a is equal to 0, we separate into two parts, phi of a which is not equal to 0 and the part which is equal to 0. Then the solution for yp is given by e raised to ax phi of a, where phi of a is the part which is not equal to 0 into x raised to r upon r factorial, where r is nothing but d minus a the whole raised to r, as we all know. This will be more clear when we see this problem. So the question is this. As you can see, this is e raised to ax term, but we do not have e raised to ax term in this equation. But cos hyperbolic 2x is nothing but e raised to 2x plus e raised to minus 2x upon 2. So instead of cos hyperbolic 2x, we can write as e raised to 2x plus e raised to minus 2x upon 2. And we know we always do this substitution, that d equal to d by dx, then our d square will be d square upon dx square and d cube will be d cube upon dx cube. So now we are going to do this substitution and this substitution in our given equation. So this part will become d cube into y minus 16. Instead of d by dx, we are writing d. 16d into y equal to 2. This is cos hyperbolic 2x. We can write this as cos hyperbolic 2x the whole square. So this is nothing but the whole square, and we have e raised to 2x plus e raised to minus 2x upon 2 instead of cos hyperbolic 2x. Now if we expand this term, this will be nothing but 2 into e raised to 2x plus e raised to minus 2x the whole square upon 2 square. So 1 2 will get cancelled and we are remain with half. This now becomes half, and this is nothing but a plus b the whole square. Okay, now we are going to apply that formula. Here we will get e raised to 4x plus 2 into e raised to 2x into e raised to minus 2x is nothing but 1. Okay, so e raised to 4x plus 2 plus e raised to minus 4x is just a plus b the whole square is nothing but a square plus 2ab plus b square. So we are using this formula here. So if I take this 2 inside, we will get e raised to 4x upon 2 plus e raised to minus 4x upon 2 plus this 2, and this 2 in the denominator will make 1. This is our final equation. If you see this equation is of the form f of d into y equal to x, where x is a function of e raised to ax. Okay, this equation is similar to this equation as I have told you. Then the solution of this equation is given by yc plus yp. We will concentrate on yc first. For yc, we will find auxiliary equation, and auxiliary equation is nothing but f of d equal to 0. What is f of d? F of d is this part, that is d cube minus 16d. So d cube minus 16d is our f of d equal to 0. Now we have to find the roots of this equation. This equation will have 3 roots. Why? Because the maximum power of d is 3. This will have 3 roots. From these two, I can take d common. So I will get d outside, and inside it will remain d square minus 16 equal to 0. This can I also modify as d square minus 4 square equal to 0. 4 square is nothing but 16. Here what I am going to use? I am going to use the formula a square minus b square. What is a square minus b square? It is simply a plus b into a minus b. So I am going to use that formula. It will be d plus 4 and d minus 4. As you can see, we got our 3 roots, where d is d equal to 0, The three roots are d equal to 0. When we equate d plus 4 equal to 0, we get d equal to minus 4. So d equal to minus 4 is another root. And when we equate d minus 4 equal to 0, we get d equal to 4. So d equal to 4 is the third root. So this will be our m1, this will be our m2, and this will be our m3. Now yc is given by c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x. Here the roots are real and distinct. So c1 is remain as it is, e raised to m1x. What is m1? m1 is 0. So e raised to 0x plus c2 e raised to m2x. m2 is minus 4. So minus 4x plus c3 e raised to m3x. m3 is 4. So e raised to 4x. This is our complementary function, and this is how we find the yc.